Okay, in this session, I will be mainly talking about string instruction. Two more string instructions. Like we saw two instructions till now. So we saw move s, okay, which does what? Copies contents to ESI from ESI and then copies to EDI. Correct, and both of them will be getting incremented. Then we saw importance of flag register by introducing set direction flag and clear direction flag, STD and CLA, like which can be used to control whether ESI or EDI value should be incremented or decremented. So whenever STD is set, like a direction flag is set, then respective register source and destination registers may get decremented depending upon which instruction you are using for the string operations. So like this is a separate set of string operations added through the set of instructions. So let us try to rather write a code which will introduce us use of this load and store instruction. Fine. So let us first see like what is this load. So again, the way that we saw for moves and scas. So similarly, this load would be available in three forms. LOD SB, so which takes AL into consideration. LOD SW, which takes AX into consideration, and LOD SD takes EX into consideration. Now what it takes is it loads value from memory represented by ESI to AL. Okay, so like I'm taking here in this case example of LODSB. Fine. So when you go with LODSW, what it will do? What are the value represented at that memory address by ESI would be taken to AX. If it is D, then to EX. Similarly, for like after this operation, okay, by default ESI would be incremented. Okay, with assumption that direction flag is not set, so it is clear. STOS. So again, three forms: STOS B, AL, STOS W, AX, and STOS D, EX. Now STOS B stores value from AL to memory address represented by EDI. It works with EDI. Okay, and with assumption that direction flag is reset, so EDI plus will happen. Okay, now we'll take an example which would be introducing us this one. What we'll do is we will have a source string. So let us say section.data. So let me add source db source string. Okay, now let me take length of it. So we'll use this directive eq $source. Okay, now let us add section.bss. I'm adding destination resb as same length. And what are the length that the earlier thing shows? Okay, so now section.text global main. So let me add external printf and test. Okay. Oh, good. So now, if I have to store this string, I know that, or we know that moves can be used to store into destination till this by making use of repeat prefix. Now we will not use repeat prefix here for a while. What we want is like what are the string that we have here should be stored in a reverse manner to this destination. Now I can carry out this operation using simple move instructions, correct? But I don't want to make use of that. correct? Because I have to store that in a reverse manner. So what I will do is, let me first write ESI comma source. Let me write EDI comma destination. Now you have ESI and EDI represented as source and destination. Now we will move to ECX the length. Okay, now let us compute what is the length right now. So one can see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 13. Okay, and then you have this 14. So let us try to see whether we can get it. So let us say push MLG, push ECX, push MLG, call LLAP, add ESP comma 8, and we will add here MLG DB LENGTH is %D 0. So let us first see what length we get. So we computed length as, let us see that. Okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, and then 14. So let us see what it shows. So ransom dash APLF 32 strrev dot asm gcc dash m32 strrev. So you can see 14. Okay, now let us go back and let us see the code again. Now, as we are representing this source address with ESI, so if I have to reach to this particular character, the last character, so I need to add those ESI. I have to take that point. How can I take that? So if I add this length is 14. So if I add to ESI, now suppose ESI is representing here, ESI plus 14. So suppose ESI is 0. So 0 plus 14. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, and then 14. Now 14 cannot be taken, correct? So that's why what we'll do is, so we'll say for a while write push A and pop A so as to preserve ECX. Okay, let us decrement ECX by 1. Now ECX would be having 13 value. So even ESI 0, ESI 1, ESI 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and 13. Now 0 would be there. I don't want that 0 to be added. So that's why what I will do is, I will write add ESI comma ECX. So we saw that it is pointing to this 0, correct? And let me decrement here ESI so that it will point to the first character. So let us write this LODSB now. So we are taking that value from ESI to be stored in EL, and we have to store now. Now between this, like our EDI is representing destination and ESI is representing source, but source now ESI is representing this G. So every time you load, it should be decremented, correct? And every time you store, this destination should be incremented. So that's the reason why we will use here set direction flag so as to decrement, and here we will write CLE. Right, and then we will write here loop. We want to decrement and then continue. So let us write LP here. Now as we are using EAX there or AX there, so let us for the sake of safety, we will have it XORed so as to make it 0. Now let us try to print. So push destination call to test and ESP comma 8. Sorry, ESP comma 4. So let us see. NASM GCC, and you can see that the source string string. So we got it printed, correct? But like I want to see this in every loop. Okay, what happens there? So let us add this thing. So we'll write push A, we'll write pop A, and we'll cut this whole thing. and we would add it here. Now let us see in every loop whatever thing is getting copied. So we will be able to see that now. Correct? Okay, so this is how you can make use of. But now let us see, like let us debug this so that we can understand it clearly. So let us display the flags because we want to flag register. Let us even display ECX. Okay, let us display character represented by EX. Sorry, I wrote it wrongly. Yeah. So let us see from where we want to run. So we do not want to print this length. Okay, anyway, because we know it is going to show me the length. So it shows length is 14. We popped all registers. So we got this. Now ECX is 14. We decremented it. Now let us display $ESI. So if I write /c, then it shows me backspace. Correct. So add ESI comma ECX now. It is showing me some character. So decrement ESX. So I'm getting some character. I don't know what exactly it is. It may be with respect to the value that we have. So NI. So C STD. Now check contents of EX. So last character is source string G. So G should be there with EX now. Can you see G? Correct, and you can see direction flag. Now if you see earlier ESI was 20, because of this STD, it got decremented. Now we are clearing this direction flag. So direction flag should be removed from here now. Let us see, direction flag is removed. Now let us display EDI. It is to be copied. This character is to be copied at this address now. Now after STOSB is done, try to concentrate on what is value of EDI. You will see that EDI got incremented. It got 44. It is now having 45. So let us say we'll have till pop A. So 8.34. Correct. So let me say continue so that it will print first character. So it is showing a G. Correct. You can see that it is showing a G. So let us say next I NI loop LP. See the ECX. It was 13. Now we are having 12. So let us continue. Now let us take next character. STD again. Say direction flag. It is 19. So it should become 18. And AL value should be N. Check. We got N. Correct. Again CLD. STOSB. Again continue. Now you will see GN. Right. So if I write continue GNI R T S space E C R U O S, and now ESI is becoming 1. Correct. So automatically, because after pop A it will be checking with the thing. So as I press continue C, that's why it is showing this. Okay, so let us do it one more time. Now when I write NI, you would be getting this revert. So I pressed continue again, that's why it was showing this. So continue. So continue. So let us go to this source first. Now we'll stop here. Okay, now let us see what is the value in ECX. So ECX is 1, decremented with 0. So ECX became 0. So it came out, it should come out of that loop. Correct. So because of loop instruction, it comes out of it, and then everything is done. So your string was already printed. Right. So that's how these both the string operations load and store works. So what we did here. So let me tell you one more time. So as we said, LOD and STOS are the two instructions that we are using, load and store. So load requires data to be in ESI, store requires data to be in EDI. These are the specific registers associated with these two instructions. Fine. So we are taking ECX length. Now we decrement, like we have seen what exactly should happen here. Okay, before loading, we are saying std so as to decrement ESI because we want to store reverse of it. And then CLD while storing, so EDI should be incremented, right? And that's how this operation works.